So in this example, we're going to apply the remainder theorem. I'm going to put slash factor theorem because they're closely related to factorising cubics. So the idea is we want to factorise p of x given by that one. Now the only way I'm going to find out those roots or zeros is by experimenting until I find one so that p of that value is equal to 0. So let's put in plus 1. 1 cubed plus 1 squared, take 9, take 9. 2, take 9, negative 7, it's negative 16. Doesn't equal 0, does it? So that doesn't work. But what about p of negative 1? Negative 1 plus 1, that equals 0. So we say that x take negative 1 or x plus 1 is a factor of p of x. Yeah?
So x plus 1 is a factor for every equation?
No, it's a factor for this polynomial.
What is a factor for all the others as well, is it?
No. That was a different example.
Oh.
So I've got my factor, I've got my polynomial, now I'm going to do some long division. I do my polynomial long division, I end up with what remainder?
0.
My remainder is 0 because of that factor theorem, remainder theorem. What's my quotient?
How do you get 0 x?
Negative 9x, take a negative 9 becomes plus, negative 9, take a negative 9 becomes plus. I'm left with 0.
No, I mean up the top.
Oh,
of the
here?
quotient, yeah.
Okay, x squared times x is x cubed. X squared times that is x squared. I subtract them, it goes away. Like that first example I gave you. And I'm just left with x squared take 9. So I know that x plus 1 is a factor. And remember, if I multiply this over there, well then I'm going to have x squared take 9 in brackets times x plus 1 are the factors of this. And then whatever the difference of perfect squares, x squared take 9 is x take 3, x plus 3, and my original factor, x plus 1. So I've factorised the cubic, haven't I? Yeah? I want you to have a go at these questions for me, please. Okay? I want you to factorise them. So remember the first step is what?
Substitute x.
Substitute values of x.
Do you always start off with 1?
Yeah, you always start off with, you can usually look at it and after a bit of practice you'll say, one's not going to work there, 2 might work though. So substitute values of x, so including plus 1, negative 1, plus 2, negative 2 and so on. Most of the problems you're given, it'll be in those first 4 starting points. So I want you to factorise all those for me, please. So you're going to do your first step, and then your second step's going to be what? Polynomial long division. Yeah? So let's have a go.